A Docker image can be 8 megabytes or it can be 800 megabytes, the exact same application. By the end of this video, you will have built your very first Docker image by hand, line by line, and you will understand every single piece of it. Welcome to the kingdom, DevOps AI Kingdom, DAC. This is the image number one of our 100 Docker image series, Zero to Architect series, where we do not just study Docker, we build it. One real image per video, command by command, all the way up to the architect level. And today we build Hello Kingdom, your first image from scratch. If you do not yet know what a container really is under the hood, watch the previous video first. The link is right above. But if you are here to build, then stay right where you are and let us go to the terminal. All right, we are in the terminal now, and it is finally time to build. Everything in this whole 100 image series lives inside one public repository called Docker Zero to Architect. And the link is in the description below, or you can see on the banner on the screen. Inside that repo, every single video gets its own folder. So let me move into the repo and create the folder for image number one. I have already cloned the repo Docker Zero to Architect from GitHub. Let me see my present working directory. We are also going step by step, and I will explain each and every command which I'll be running in the terminal. So for checking the present working directory pwd, it will show in which folder we are in right now. So if you see here, we are already in Docker Zero to Architect. Let me list the content of the folder. You will see there is a cheat sheet, lessons, and readme.md. But we need to create a image folder so that inside the image folder, whatever images we are creating, we are adding it one by one. And right now we are creating our first image. So I'll put the name of that image as 001 Hello Kingdom. So for creating a folder, image folder, we use command mkdir, that is for make directory. Hyphen p is for nested loop. Like if you want to create multiple folders, one inside other, then hyphen small p is required, and then folder name images, and we are making our first image. For that also we are creating a folder which is named 001 Hello Kingdom. When you run it, when you enter it, and again list or everything, so you will see a new folder got created and it's a directory. These are the permissions actually, if you see on the screen. uh, and d means directory. So let me go inside the images folder, and we'll see there is a 001 Hello Kingdom. So if you see, when we run mkdir hyphen p, so it is created two directories by default, because we used hyphen p option. So it is also a directory. So in this directory we will add all the required files for our application, for our image which we are going to build. And now pay attention to where we are standing right now. So let me go inside 001 first. Then again, uh, it's empty, and and pwd present working directory. So we are inside under Docker Zero to Architect, then images folder, then 001 Hello Kingdom folder. So pay attention to where we are standing right now inside 001 folder, because in about 2 minutes you are going to see why being in the wrong folder is a single most common beginner's mistake in all of the Docker. Since we are creating our first image, so every image needs something to actually run, and ours is going to be the simplest possible program. people start with hello world. We are not going to do that. We start with a tiny shell script that prints a banner to the screen, and I am going to use the vi editor because vi is on literally every linux server you will ever log into. Let me open a file and create our script. Vi banner.sh. So we are inside our file now. Vi just opened, and here's the thing that confuses everybody on day one. Vi did not open ready for you to type. It opened in what is called a normal mode, and where the keys are commands, not text. To actually start typing, I press letter I, which stands for insert mode. So watch the bottom left of the screen. The moment I press I, it now says dash dash insert dash dash. So that is how I know I can type now. And now let me put the content for the script. Look at the very first line of our script, the one that start with hash and then an exclamation mark, and followed by slash bin slash sh. The line has a special name. It is called shebang, and it's just it to tell Linux which program should run this file. In our case, the shell located at slash bin slash sh. Every executable script beings with shebang, so never skip it. Now, let me save it and quit. And this is the part people get stuck on. So watch closely. First, I press escape button. That takes VI out of an insert mode because to normal mode and the insert mode label at the bottom disappears. Then I type a colon, which lets me give VI a command. So column is needed to put commands in VI editor, followed by W. W is for write, and that means save. And Q is for quit. So colon WQ and press enter, saves and quit actually. Uh, if you ever get lost in VI, just want out without saving, the escape hatch is escape, then colon QA exclamation mark and then enter. We'll talk about it later. There is one more small thing that people always forgot, and it caused real bugs later. I need to make this script executable right now before it goes into the image, because Docker copies file into the image together with their permissions. This is one of the most important thing. Docker copies file into the image together with their permissions. If I fix the permission here, it just work. If I forgot, I get a permission denied error deep inside a container later. So we fix it here. First, let me show you the permissions. If you see when you do ls-la, then our banner dot has sh script does not have a executable permission. For that, we are using the command chmod plus x is for executable and the file name which we want to make it executable. So chmod plus x adds the executable permission to the file. Chmod is a short for like change mode, and plus x means add the executable permission. If you want to actually see that it work, uh, list the file in long form and look for the little x in the permission, that is ls-l followed by the file. So if you see x has been added in user group and others for all the permissions. See those see these letters on the far left, something like rwxr-xr-x, where X means this file is allowed to run. That is the meaning of execute. Before chmod, they were not there, so now they are there. A small detail, real bug saver for future. Now we write the single most important file in this entire series. That's the Docker file. So what is a Docker file? It is simply a plain text file that contains step-by-step instructions for Docker. Docker reads it from top to bottom, runs each instructions, and the result is an image. Think of it exactly like a recipe. The Docker file is a recipe. The image is the sealed cake mix that the recipe produces, and a container is the actual cake you bake from that mix. And the beautiful part is that this turns the setup of machine into code. The same Docker file produces the same image of any computer every single time, and it lives in Git just like real code. That idea has a name in our industry called as infrastructure as a code. Let me write our very first one, and it is only 3 lines. Same via rhythm as before. I open a file. Remember, press I first to start typing. So vi and Docker file always start with capital D. Docker file, capital I for insert mode, then 3 lines for Docker. Before I explain each line, let me explain a grammar of a Docker file. Because once you see it, every Docker file on earth becomes readable. Every line has the same shape and instruction in capital letters. If you see, let me create a separate file here. So if you see all these capital letters, those are instructions in capital letters followed by its arguments. The capitalized word from copy cmd is the instruction. It is a fixed command that Docker builder understand. There are only about 18 of them in the whole language. Everything after the instruction is the argument and the actual data it works on. We write the instruction in uppercase by convenience, so your eye can instantly separate the command from its data. So from is an instruction, and Alpine 3.20 is its argument. Copy is an instruction, and its two argument are banner.sh/banner.sh. Now CMDA is an instruction, and whatever is inside the brackets is a argument. That is the entire grammar, and we have 18 of those for Docker. And here is the architect level instruction to file away. Some instructions build actual file system layer from run, copy, and add. Uh, Physically add files. Other instructions only write metadata. Settings stored about the image and add 0 bytes. That is, again, some instructions build actual file system layer like from, run, copy, add physical files to add files. Other instructions only write metadata. Setting is stored from the image and add 0 bytes. That is like CMD, ENV, label, expose, work directory, and so on. Now let me explain all three lines because each one carries a lot of meaning. The first line from the first line from Alpine 3.20 means every image has to start on top of a base image in Docker and are start on Alpine, which is a tiny 5 megabyte version of Linux. From must always be the first real instruction in any Docker file. You cannot build on nothing. And notice that I pinned the exact version 3.20. Never ever write the word latest here because latest can silently change tomorrow and break your build. Pinning the version is an architect habit and it's a start today on image 1. Now the second line, copy banner.sh and followed by slash banner.sh. So it is copying a file banner.sh from our local machine in the same folder to banner slash banner.sh inside the container. So left side is my folder. There's banner.sh. Left side is our folder. It is called the build context we are standing in. And the right side is the path inside the image. This is going to be the inside the image. One file across the border. Okay. And the third line, CMD with the script in square brackets. So is the one command that container exit to exist to run. Now I want to slow down here because this little detail separate people who just copy Docker file from people who actually understand them. There are two ways to write CMD here. The way I wrote it and the square brackets and codes is called the exec form. So this is called exec form. There's also a shell form where you would write CMD and then just the command with no brackets at all. They look almost identical, but under the hood they behave very differently. And here is the difference. With the shell form, no brackets, Docker secretly wraps your command into a shell. It actually runs slash bin slash sh dash c, and then your command is text. So again, here is the difference with the shell form with no brackets. This line number 8, if you see, Docker secretly wraps your command inside a shell. Okay, it actually runs slash bin slash sh. So the PID uh, one is bin sh, and your script is a child of sh shell script. Okay, so why does that matter now? Because of something called PID1. So what is PID1? Inside every container, the very first process gets process ID number 1, and the PID1 is very special. It is the boss of the container and the init process. Two rules apply to PID1 specifically. Rule number 1 is when PID1 exit, the entire container stops. Rule number 2 is, this is the most important one, when you run docker stop, Docker sends a stop signal called sigterm, that is sigterm sigterm, and it sends the signal only to the PID1, signal to PID D1 to stop. So now connect the dots. with the exec form, which is this one, which we used in uh, uh, our image. So with the exec form, our script is PID1. So the Docker stop reaches your program directly and it shut down cleanly and instantly. But with the shell form, where shell is the PID1, our program is not the PID1, but the shell script got the PID1. Uh, so our script is just a child. That shell usually ignores the stop signal and never passes it down to your script. So Docker stop appears to do nothing, and Docker waits 10 full seconds and then force kills the container. That is the source of those annoying slow 10-second shutdown you see in real production system. This is why system container force kill after 10 seconds. So the rule is simple: always use exec form, the square bracket, so your real program runs as PID1 and handles signals correctly. And remember this too: the container will live for exactly as long as PID1 process lives. Hold on to that, because it is about to explain something that confuses everybody. So I save and quit the same way we did our file. So this 3 lines: escape, then WQ, enter. Now let me print the file straight to the screen with cat command, just so we can see it cleanly without an error. Cat command is simply for show the content of the file. Okay, let me clear a screen first, so it will be neat. And then cat uh, docker file, we will see our 3 lines are there. Okay, so file got created from via editor. Now this is the moment of truth. uh, we are going to build our image. So for building our image, we use command curvel hyphen t kingdom. Let me read this command out loud, every piece of it. So docker build means what? The docker build means read the docker file and produce an image. That is the docker meaning of the docker build. Read the docker file which we have created and produce an image out of it. The dash t gives an image a name and version. Without a so if you want to give our image a particular name, we have to use hyphen t. And for any particular version like 0.1, we use dash t option. In our case, hello kingdom colon 0.1. Without dash t, you would get an ugly random string of letters and numbers that is useless to an human. And then there is a dot at the end, right at the end. This dot, the dot is the build context. It means use this folder, the one we are standing in. If you forgot the dot, Docker yells at you. Like if you are in wrong folder, the copy line cannot find banner.sh. This one, this copy will tell you this banner.sh is in the same folder where our Docker file is. So that this dot is showing our build context. Now watch the output as we run this command. So it pulled Alpine down from the Docker hub because we did not have it, and then it copied our script in. Each line on a Docker file become a layer. So we have 3 lines, so we have like 3 layers. Now watch this little piece of magic. I am going to run the command again. Let me clear it. Look at it now. Every step got cached. If you see here, cache is there. Okay, so every step is cached and it finished in under a 1 second, 0.4 seconds. Docker never builds a layer that has not changed. This cache is going to save you hours of our life. And around image 18, I will show you the classic mistake that accidentally destroyed. Now, before we run, before we run this image, let us actually look at what we just made. Three quick commands. First, list the image on the machine. So clear. So because when you do list folder, you only see Dockerfile as a banner.sh. Let me remove this demo. Demo. So if you see banner.sh and Dockerfile is there. So where did this when we create a image, where did that image go? For that we have to run Docker images. Now you will see Hello Kingdom 0.1 image has been created. Okay, it shows 26 hours. I think I have created the same image earlier, so it is showing that. But we just created, so you can take. You will see the repository name Hello Kingdom, tag is 0.1. Uh, so this is the Hello Kingdom with 0.1 image, and we have an image ID which is really a hash of its content. And look at the size, about 8.8 MBs. So a complete shippable Linux application in 8 megabytes is ready. Your virtual machine template is 40 gigabytes, but let us look at the layers inside. Now we want to see layer by layer. For this, for that, we use Docker history command. History and image name, image 0.1. So when you run it, this shows the layers and you read it from bottom up. Alpine-based layer first, then our copy, which is only a few hundred bytes, then CMD with which is 0 bytes. And because CMD does not add any file, it only writes a little metadata. Layers are real and you will completely master them at image 27 with tool called dive. And the third command in the X-ray machine of a Docker is Docker inspect, which dumps everything about the image as JSON format. And I will filter it down to just the command we want to see what command we have run in our Docker. So if you remember, cat Dockerfile. So we just run banner.sh. So how to inspect our image with that? So we use Docker inspect Hello Kingdom format in config.cmd. It will show us there is our cmd command backed right into the image, right? Remember this inspect because we are going to lean on it constantly through this series. Now let us run our very first hand built container. For that we are using command docker run and the image name which we have created, enter it. So this is our banner, right? We build an image out of nothing and we ran it. But now here is the question that confuses every single beginner on the planet. Where is that container now? How I can see the container? So for that, let me list the container. For that we use local ps. But it is empty. Did it break? No, actually no. And let us kill this confusion forever right here. The command docker ps only shows container that are currently running. Our containers process the banner script already finished. It already showed the script and then it exit. So we have to add dash hyphen a, that is for all the containers which are in exit state or which are running. Okay, so when I run this you will see, and there it is. Okay, status is exited 59 seconds ago, and zero, exit code zero means success. The process is finished, so the container finished, because a container lives for exactly as long as it's one process. Nothing is broke. This is the design working perfectly, and look at the name columns. Docker give our container a random name: relax, Ptolemy, Ptolemy, whatever it is. So Docker gave our container a random name, something like nostalgic, uh, relaxed, whatever it is, because we never give it one ourselves. So there is a flag to fix that, and it in coming lectures, coming videos, we will fix it. I'll show you how to add the name to a container. But watch a trap that every beginner falls straight into. That is running a container again. Okay, I run Docker run Hello Kingdom 01 again. Okay. Then do Docker ps hyphen a, list all the containers again. You will see there are two exited containers now. Every time you type Docker run, it creates a brand new container from this image, and it does not reuse the old one. One image, many containers, exactly one cake mix, like many cakes. Run it 50 times and you will get 50 dead containers piling up on your machine. So how do a real engineer avoid that pile? With the dash rm flag. That means when we run docker run, if you add hyphen hyphen rm image name, that is hello kingdom 01, when you wait, we did something wrong. Let me see it. Docker rum. It should be run. We don't need rum. Okay. So now when you do, we already have, like, we are running it third time. So Docker ps hyphen a. If you see the third container which got exited is not showing here. So wo- what this dash rm means actually, automatically deleted this container the moment it exits. And for that means the run and done container like this. And we should always use it in production to clean up the two dead containers we already created. And I use docker rm. Now we want to delete these two containers. Okay, also. So for that we have a command docker remove rm, that is, then dollar sign will take a value, uh, that is docker ps hyphen aq. Let me read this one first, because it is clever. Docker rm removes container. The part inside the brackets, Docker ps dash aq. Here the q meaning quit, and prints only the IDs of the container, nothing else. So the whole line reads: remove every container ID that exists. But wait, actually, let me keep one alive for next step. We just need one container at least. So let me run it again, because when I do docker ps, sorry, docker ps hyphen a, nothing is there. So let's run the container again, and our banner is already there. Okay, now we have to build a new habit, like one more habit we build from day one today. That is, real engineers do not guess what their containers are doing, they look. So let me introduce a tool called Lazydocker for installing. For installing a tool, you if you are on Mac, you can just run brew install lazy docker, something like that. I already installed. I'll put the link in the description or in GitHub repo how to install it. So once you already because I already have lazy docker. Let me see, lazy docker hyphen version. Yeah, lazy docker is already there on my MacBook. So to to run lazy docker, just run the command lazy docker, enter. So this is the full dashboard right here in the terminal. Okay, I use the arrow command to move up and down, and here is our exited hello kingdom containers. I press enter, and there are its logs. So if you see, if I go to exited container, okay, by arrow commands, and then when I put enter, you will see the logs, stats, environment, everything about our container. So here we can see like containers, images, volumes, networks, everything associated with our container and image. Okay, so this is a tool we are going to use very often, and we should use in like for our own purposes when we are working in production. Like we have other tools, but for our internal purpose, like for our local desktop and all, this is one of the great tool. We should use it. Okay, so a last step now, and we are going to do this on every single video because real engineers save their work. First, I put all my today's commands into a file called commands.md, so that anyone watching can copy paste and every command straight from github and save it, uh, like from using vi. Now, once we done that part, let me move back to the top of the repo and save everything into the Git. For that, uh, so moving out of the lazy docker, we just put Q, and then let me go back to my repo where my .git is there. Okay, then I am going to push it to git add images. So let me narrate this. Git add stage. Git add stages are new folder, and then we will commit so that we can push it to git commit hyphen n image. So we are going to use this kind of format: image, number, name, and concept for git commit. Push. I think I have already updated, push this code. So let's wrap up what we have done in this video and what we have understand. So let me recap what we just learned and count it on your fingers, because it is a lot for video one. You learned how Docker works, the client, the daemon, images, containers, and the registry from the previous video. And you learned what a Docker file is, the three instruction from copy and cmd. We have learned Docker build with a tag and the all important build context dot. You learn the layer cache, and you learn Docker images history and inspect command. You learn Docker run and the difference between ps and ps hyphen a and exit code 0. The fact that one image makes many containers, and the dash dash rm, like rm flag and Docker rm, what are those? And on top of all that, we have also learned to observe with Lazydocker, and you save your work in Git. That is image number one of 100, and this is the pace every single video will be. And here is your interview moment for today. When they ask you what is the difference between a container and a virtual machine, most people mumble something about lightweight. You are going to say a virtual machine virtualizes the hardware and boots a full operating system, while a container is a normal Linux process isolated by namespaces, limited by C groups, and sharing the host kernel, which is exactly why it starts in milliseconds and dies together with its process. Crisp senior, and you can say it because you just build it now. Now for the homework, like build this exact image yourselves, run it twice, find the two dead containers, clean them up, Docker RM, then find the survivor in Lazydocker. And when the mental model finally clicks for you, drop a comment that says process with a crown, because I read every single one. In the next video, image number two, static website. We build our very first long running container, a real web server running in your browser from from an image you build with a name that you choose, and that is where ports will enter into our story. Subscribe, join the kingdom, and remember, don't be same, be better. And let me remove everything, so that we should clean up everything after we have completed our demos. So for that, Docker RM, using the same command $docker ps hyphen aq. And now when I run Docker ps, no container is there. Docker ps hyphen a, nothing is there. Cool. See you. Welcome to DAC again.